All right, so let's use some fundamental identities here to figure out if we can find the exact value of these given expressions. So first off, we're told that tangent 65 degrees times cotangent 65 degrees. What is the exact value of this? Now, one of the ways that we can use our identities to help us in this is that tangent and cotangent are reciprocals of each other, right? So tangent t is equal to 1 over cotangent t. So I can actually use that to help me here. That would mean that tangent of 65 is the same thing as 1 over cotangent of 65 by this property. So this tangent here drops down to the 1 over cotangent, and we are multiplying that by cotangent of 65 that we had here. Well, rules of fractions, if you have the same thing in your numerator that you have here, that you have in your denominator, those are going to cancel with each other, which means this is really just a 1. 1 over cotangent times cotangent simplifies merely to a 1. For this example, we are told that cosine of t is equal to 1/6, and we are told that sine t is less than 0. Let's find sine t based off that information. Now, the given property that we want to use for this example here is we want to use that cosine squared t plus sine squared t is equal to a 1. And we want to plug in what we know. So we are told that cosine is equal to 1/6. So that means when we plug in here, this is cosine squared, which means we are going to have 1/6 squared plus sine squared t is equal to 1. Finish solving this for sine, and we have our answer here, which means square the 1/6. If we square 1/6, that is 1 over 36. We want to go ahead and move that number over to the right-hand side, so we are going to subtract 1 over 36 to that side here so that it can cancel on the left, and we are left with sine squared t is equal to, going ahead and calculating 1 minus 1 over 36, we can change that 1 to a 36 over a 36, right? 1 is equal to 36 over 36. So that when we subtract this here, we are left with a 35 over a 36. Which means the only thing left in order to finish solving here for sine is take the square root of each side. Remember, we're solving for sine. We have sine squared here. So we're going to take the square root of the left, which is going to leave us with sine t. On the right-hand side, simplify that radical. Keep in mind that the square root of 35 over 36 is the same thing as the square root of 35 divided by the square root of 36. The square root of 35, we cannot simplify that, so we will drop that down. But the square root of 36 is a 6. Now, this would typically be a plus or minus here because we are working with a radical. But keeping in mind, going back up to our stipulations here, we were not only told that cosine is equal to 1/6, we were also told that sine is less than 0. So for our final official answer here, our answer is not the plus or minus. The fact that we were now told that sine is less than 0 means that we're going to go with the negative option here, and sine t is equal to negative square root of 35 over 6. For this next example, we are asked to find the exact value of secant of negative 960. Now, first off, we are given a very, very large angle here. 960 is not within the parameters of 0 and 360. So keep in mind, we always want our radian measure between 0 to pi, our degree measure between 0 and 360. So if we're given a very, very large measure, we want to find its coterminal angle here. Since this is negative 9/360, you just want to add 360 until you get something between 0 and 360. So if we keep adding 360 to this, we would end up with secant of 120 degrees as its coterminal angle. Secant of 120 degrees then has brought it into a positive angle. We simply just need to find secant of 120. Keep in mind that secant is 1 over x. If we take a look at the actual coordinate, secant of 120, so the actual coordinate is negative 1/2 square root of 3 over 2. But again, keep in mind that secant is 1 over x. So that's going to be 1 divided by our x value, which is the negative 1/2, which is the same thing as 1 times a negative 2. Secant of negative 960 would end up being a negative 2. Now for our next example here, we're given sine of negative 30. That 30-degree measure is between a 0 and a 360. Sine of negative 30, this is going to reference our even and odd angles here. Anytime we are given sine of a negative angle, according to our even odd properties, sine of a negative value is the same thing as negative sine of that positive value. So what that means for us here is this negative that's inside here, that negative is now going to be pulled out here to the front, and we're going to find negative of sine of 30 degrees. The coordinate at 30 degrees is square root of 3 over 2 and 1/2. Keep in mind that sine is going to be your y value here. So negative sine of 30 degrees, move over that negative. Sine of 30 is the y value, so the y value here is a 1/2, so that means negative sine 30 is negative 1/2. Now for this final example over here, we are given cotangent of negative 19 pi over 4. We want to find the exact value here. That negative 19 pi over 4 is too large, or technically I guess too small since it's negative. So we want to bring it within 0 and 2 pi. So we're going to do that, add 2 pi until we have an appropriate measurement. Also keep in mind, our even and odd properties, cotangent of a negative measure is the same thing as negative cotangent of that measure. Okay, so cotangent of negative 19 pi over 4, according to our even or odd property here, pull that negative out to the front, and we're going to find cotangent of 19 pi over 4. Now, in order to get this angle to something that we can work with, we are going to, technically here, since it's now positive, we're going to subtract 2 pi, we're going to subtract 2 pi to get us a measure between 0 and 2 pi, right? We're going to find the coterminal angle here. Coterminal angle of cotangent of 19 pi over 4 would be 3 pi over 4. So we're going to find the value for negative cotangent of 3 pi over 4. Now, the coordinate for 3 pi over 4 is negative square root of 2 over 2, comma square root of 2 over 2. So let's drop down our negative and taking a look at cotangent. Cotangent is equal to x over y. So we want to take our x value, which is negative square root of 2 over 2, and we are going to divide that by our y value, which is the square root of 2 over 2. Which, doing this by hand, again, either throw this into your calculator, reducing this by hand, double negative rule in the front is going to make that square root of 2 over 2. Change the division symbol to multiplication, and flip the second fraction. We can see here square root of 2 is going to cancel with square root of 2. 2 is going to cancel with 2, leaving us with a positive 1 as our solution.